Welcome to the Explainer. Have you ever looked at the world around you and just felt like there are these hidden rules holding everything together? Well, today, we're going on a journey to find that secret language, the language of math. But not in a textbook. No, we're going to find it in the patterns all around us. So let's just jump right in with a big question. When I say the word math, you're probably picturing, numbers and equations on a chalkboard. But what if I told you that its real power is hiding in plain sight? Where is the math, really? Could it be right here, woven into the very design of this basket? Think about it. Every single thread follows a precise, predictable path to create something that's not only beautiful, but incredibly strong. That's a pattern. Or what about here? Is there math in the rhythm and flow of a story that's been passed down for generations? Absolutely. There's a sequence, a structure, a pattern to how the story unfolds.
And just look at the stunning geometry of a dream catcher. Every single knot, every space, it's not random at all. It's a specific point in a much larger design, each one holding a unique, calculated place in the web.
And this is really the heart of it all. Math isn't just about crunching numbers. It's a powerful language we use to see and describe the hidden patterns that connect everything, from the basket to the story to our place in the entire universe. Okay, with that in mind, let's grab our first tool for this journey. It's a special kind of map, one that's designed to help us find our place, not just on land, but inside the world of numbers itself. This amazing map is called the Cartesian plane, and the genius of it is how simple it is. You just take two lines, one that goes across the x-axis and one that goes up and down the y-axis, and suddenly you can give a unique address, a set of coordinates, to any point you can imagine.
And right at the very heart of this map, we have the origin. This is point 0, 0. It's where everything crosses, that one central foundational spot from which every other location is measured. It's the starting point.
Now get this. This mathematical map isn't some abstract idea floating in space. It actually mirrors profound cultural symbols, like the medicine wheel. Just look at the parallels. Both systems use 4 distinct quadrants and have a powerful central point where everything connects to represent balance and our place in the world. It's an incredible connection. All right, so we've got our map for finding a single location. But what's next? Let's see how we can use it to do way more than just pinpoint one spot. Let's start charting entire stories as they grow and unfold through patterns. I want you to think of mathematical patterns as stories, okay? Stories that unfold in a predictable, totally logical way. In fact, our source material talks about this through tales of a character named Small Number, who uses his skill at spotting patterns to solve real-world problems for his community.
So, when a pattern grows by the exact same amount each time, like a weaver adding 3 new rows every hour, we call that a linear relation. And when the things we're counting are whole things you can't split into fractions like beads or people, we call the pattern discrete. And you know what that looks like on our map? A perfectly straight line of dots. Here's a super simple way to think about it. You can count 1, 2, or 3 canoes, right? But you can't really have half a canoe. That's discrete data. Continuous data, on the other hand, is something like the water flowing in a river, something you measure, which can be any value at all. For today, we're going to be focusing on that countable, discrete world.
Okay, so we have our map, and we get that patterns are basically stories. Now it's time for the master key. This is a super simple 3-step method for reading and even writing the rule for any of these straight-line patterns you find out in the wild.
Let's work through a great example from our source material to see how this works. Imagine Small Number is learning traditional beadwork. His grandmother gives him 2 really special beads to start with, and every day after that he earns 3 more. So the question is, how can we figure out how many beads he'll have on any given day without counting them all? Step 1, and this is the most important first step, is just to organize what we know. A simple table like this lets us see the story that the numbers are telling. So on day 0, before he even starts, he has those 2 beads. After day 1, he's up to 5. After day 2, he's got 8, and you can see how it goes from there. Now for step 2, we just need to be detectives for a second. We're going to look closely at our table and find 2 crucial clues that are going to unlock this entire pattern for us. We're looking for something called the jump and the start. The jump is just how much the number of beads goes up each day. You can see it, right? It goes from 2 to 5. That's a jump of 3. Then from 5 to 8, another jump of 3. It's always 3. And the start?
Well, that's just the number of beads he began with on day 0, which was 2. Simple.
And really, that's the whole method. You organize your data so you can see it clearly, you find that jump and that start, and then you just combine them into a rule. This simple process is the key to cracking the code on any linear pattern you'll ever find.
All right, step 3, let's build this rule. We start with our jump, which we found was 3. Now, since he gets 3 beads per day, it makes sense that we multiply it by the day number, which we'll just call n.
So that gives us the first part of our secret code, 3n. 3 beads for every single day that goes by. But wait, we're not quite done yet. There's one more piece to the puzzle.
All we have to do now is account for where he began. We just add that starting amount his grandmother gave him, which, if you remember, was those 2 special beads.
And there you have it, our final rule, 3n plus 2. This isn't just some random equation, it's a powerful tool that tells the story of the beads. We can use it to predict exactly how many beads he'll have on day 10 or day 100 without counting a thing.
So what's the big takeaway from all this? Well, you now have the tools. You've got the map, the Cartesian plane, and you've got the 3-step key to unlock any linear pattern. You can now officially find and read the mathematical stories that are hiding all around you, whether it's in a weaver's design or a family tradition.
So now it's your turn. The next time you see a repeating pattern, maybe in a building, on a piece of fabric, or even in a line of trees, I want you to look a little closer. See if you can find its starting point. See if you can find its jump. And then ask yourself this: what story will your pattern tell?